Well, hello and welcome to this exercise on finding area under the curve by integration. Now this is an IGCSE or based on IGCSE question, so I'm not going to answer the question straightforwardly as you will expect in an exam. So it's going to take a bit longer than you do in an exam. Hope you bear with me. It says figure 2 shows the curve C with equation y is equal to 50 plus 2x minus x squared. And then it goes on to say that the curve crosses the x-axis at the points A and B. And then part A says, find the x-coordinate of A and the x-coordinate of B. Now to find that, I have to find the x values from here, 15 plus 2x minus x squared. Now, I think this can factorize, so I'm going to try and factorize this expression here. And to do that, I'm going to use the splitting and grouping method. Now, I've got a constant term of 15, and I've got that the coefficient of x squared is minus 1. Now, minus 1 times 15 is minus 15. And now I need two numbers such that when I multiply, I get minus 15, and when I add, I get 2. And the numbers that come into mind are 5 and 3, because 5 and minus 3, because 5 times minus 3 is minus 15, and 5 minus 3 give me 2. So now this is what I've got now. I got 15 plus 5x minus 3x minus x squared. Now 5x minus 3x will give me 2x. So I've made the difference at all to the original expression. And now I've got two groups. This one here and this one here. So now I'm going to group them. I'm going to try and factorize both groups, and I end up with 5 into 3 plus x minus x into 3 plus x. Now both groups have got 3 plus x in common. And now when I combine both groups, I have this here, x plus 3 into 5 minus x. So either x plus 3 is 0 or 5 minus x equal to 0. That will give me x plus 3 is 0, which if x plus 3 is 0, then x is minus 3. And if 5 minus x is 0, then x is 5. So my answers to part A are going to be x equal to minus 3 for the point A and x equal to 5 for the point B. Right. For this one, it says use calculus to find the area of the finite region bounded by C at the x-axis there. And this suggests to be using integration there within limits there. So I'm going to try and integrate this expression here with respect to x, and then I have this here. And my limits are 5 and minus 3. And when I integrate, I have that 15x plus 2x squared over 2 minus s cubed over 3. Now I'm going to cancel the 2's in the middle term. So we'll now end up with, and of course our limits are still 5 and minus 3. Now I'm going to substitute these values of 5 and minus 3 into this expression within the bracket there. So now I have, for the first section with 5, I get 75 plus 25 minus 125 over 3 minus what I get when I substitute with minus 3, and that's that one there. And when I combine both sections, I end up with 58 and 1/3 plus 27, and that will give us 85 and 1/3 units squared. And that is the area, the whole area under this curve, the whole thing. Okay, so that makes sense. Next slide. Right, now for part C and for part D for that matter, because this first line, the line L with equation y is equal to x plus 9 intersects C at the points R and S. Now this first line applies to both part C and part D. Okay, now for part C, the question is um, find the x coordinate of R and the x coordinate of S. Okay. Now, where the two, uh, where the curve and the line meet, the y values is going to be the same. I need the y values are the same. Then the x values will also be the same. That the y coordinate value that is, and the x coordinate value will be the same. So now we have y is equal to x plus 9, y is equal to 15 plus 2x minus x squared. So they must be equal, because where they meet, the y and x coordinates will be the same. So now what we do, if we then add x to both sides, subtract 2x from both sides, and subtract minus 15 from both sides, we then end up with x squared minus 2x minus 15 plus x plus 9 is equal to 0. And when we combine like terms, we end up with x squared minus x minus 6. And now I'm going to factorize as before using the splitting and grouping method. Now the coefficient of x squared is 1 and the coefficient of minus 6 is, the coefficient of x squared is 1 and the constant term is minus 6. And 1 times minus 6 will give me minus 6. Okay. Now, I want two numbers such that when I multiply, I get minus 6, and when I add, I get minus 1, because minus 1 is the coefficient of x there. And the two numbers that come into mind are 2 and 3, because 2 and minus 3, because 2 times minus 3 will give you minus 6, and 2 minus 3 will give you minus 1. Now I'm going to group, and then factorize. So I end up with x squared plus 2x for the first group, and 3x plus 6 for the second group. And when I factorize this group and the other group, I get x into x plus 2 minus 3 into x plus 2. Now both groups have got x plus 2 in common. And when I combine, I get x plus 2 multiplied by x minus 3. So either x is equal to minus 2 or x equal to plus 3. So and that's what we got there. So for R, we got x equal to minus 2. And for S, we have that x is equal to 3. Okay, hope that makes sense. Next slide. Okay, now this is the last slide of this question. I'm sorry it's taking so long, but you know the whole question carries 40 marks, so I'm not surprised. Quite a big chunk of marks there. Okay, and then it says use calculus to find the area of the region bounded by C, the line L and the x-axis shown shaded in figure 2. So we're looking for this area there. Okay, right. What you need to do, we also need to find, in order to find this area here, it makes sense to find what this area, the unshaded region is. So what I've done is to draw 3 graphs. Okay, now this is the whole graph, and we know that the area there from part A is 85 and 1/3, I think it is. Okay, now what I need to do now is to find the area A, B, C, D, and E. I also need to find the area A, B, X, D, and E there. Now when I subtract A, B, X, D, E from A, B, C, D, E, I get the area of the unshaded region there, or there if you wish. Okay, so now I'm going to integrate within the limits of S and R, and S is 3 and R is minus 2. So that's what we got here. Now that bit represents the curved region, the curve within the limits of 3 and minus 2. Yeah, 3 and minus 2, that's S and R. And that bit represents the region under the line again within the limits of 3 and minus 2. But then when I subtract these two, what I have is the area of the unshaded region. So now if we then simplify this expression, we have 15 plus 2x minus x squared minus x minus 9. If we then combine if we combine like terms, we end up with integrating 6 plus x minus x squared within the limits of 3 and minus 2. Okay, so we end up with 6x plus x squared over 2 minus x cubed over 3, and the limits are still 3 and minus 2. And as before, we substitute 3 into 6x into x squared minus 2 and x cubed over 3, and then of course use minus 2 as we did earlier. All right. So when we substitute 3 and minus 2, we end up with this here. So that will be for 3, and that will be for minus 2 there. And when you subtract both, you end up with 20 and 5/6 there. Now this area, this one here, is the area of the unshaded region. Now to find the area of the shaded region, we have to subtract this 20 and 5/6 from the whole area, which is 85 and a third for part A. And we end up with 64.5 units squared. Now I hope all that makes some sense. Please subscribe, and thank you for watching. Bye bye now.